Welcome back to Chapter 5 of America's Boating Club's Sail Course. In this chapter, we will be covering sails. Let's go over some of the parts of the sail as we look at them. We've got, each sail has the top of the sail, that's called the head. The bottom of the sail is called the foot. The front part of the sail is called the luff. This is both the main as well as we've got a jib. The front of the jib is also called the luff. It has a head and the tack and the clew. We also had, another part this is called the leech back here, the back part of the sail. Now, if we were able to draw a straight line from this point here to this point here, there's some cloth that's longer that overlaps that area, and that is called the roach. But if we didn't, if we just had that straight part hanging out there, it would flap like a flag. And so what we have to do is we put reinforcements are built into the sail and to keep it from falling off when we're going upwind. And we put, these are little sticks or pieces of fiberglass that bridge across from the back of the sail up to the main part of the sail. It's called a batten. And in order to keep those in place, we have batten pockets. Sails often have, the way we attach them is through a hole in the sail at the corners. And these corners have a grommet and it's called a kringle, where the shackle or attachment point is. It's attached in three places. We've got the outhaul, which is the outside corner. We've got the front port. The outhaul pulls out the clew. The front part is a tack. It's tacked down at the front of the sail point, we also have a grommet at the top of the mast at the head that are where our halyards are attached. Some sails may have reef points built into them where you can actually lower the sail down and sail with less area. And you would use these reef points when the wind gets really strong and you want to depower the boat. This is a better example of the roach. That's the back part of the sail. That's past this particular point from the head to the foot. That's the straight line. And this cloth area out here is called the roach that leads back to the leech. By doing this, we can actually add extra sailcloth to our sail. And sail area is essentially the horsepower that makes the boat go. In order to keep this area here from flapping, we have to add battens to stabilize the material. And the batten would run from the back part of the sail across over here to this part of the sail. Here's a picture of the headboard that's built into the top of the sail. It's extra reinforcement that's built into the sailcloth because that's one of the high stress points. In some of the newer boats, modern era, this headboard can be, on my boats, they're probably 3 or 4 inches wide. But on some of the more modern boats, they have some rating rules where this headboard actually could be several feet long, which then gives it extra performance upwind. As we discussed last week, there's a lot of ways to attach the sail to the mast. In this example, we actually have the mainsail attached to the mast using a set of slides that slide up and down on this track as you raise the sail up. In this example, we have a sail where a rope is sewn into the front of the sail, the luff, and then it goes into a track in the mast. So the sail has a piece of rope built in here. The mast has a track, and it slides up in the track through an opening. This shows us an example where we're using slugs to connect the sail to the mast. In this case here, we have the mast track and the slugs slide in this groove like was in the bolt rope, and then that's how they are raised and lowered. In this case here, we're talking about a jib and its various parts. Just like the main, it's got a head, a tack, and a clew. And then each one of these corner points, you can see there's some extra cloth that's been built into the sail, sewn in to give further reinforcement, because these are very high load areas, and if you didn't strengthen them up, they would distort very easily. The way we attach them to the boat is we attach them to the forestay or jib stay. So this is the cable that goes up to the top of the mast that holds the mast up, and then we attach the jib to that forestay. In the old days, we would have used a heavy piece of metal that actually had a snap on it to make it to go around the forestay wire. Most boats now use a piece of cloth that attaches to one side, a little tab that goes from this side of the sail around the forestay and then snaps back onto the sail itself. And so that's, that provides then that security, and all these snaps then hold it in place. We've got a lot of different sail configurations on a sloop, so that we can kind of control the amount of horsepower sail area that we use for depending upon the day. So in this example, we've got what we call a working jib. And by definition, the working jib is really about the same size as that fore triangle area. So the fore triangle area is this part here, and you can see that the jib just generally fills it up. Yeah, it might overlap just a little bit, but that's what we call a working jib. In this illustration, we're really talking about the Geno Jib, and what it is it's like a jib. It's just much larger, and the original the first jib was about this big. Well, you can see that the Geno goes much farther back, and what it does is it gives the boat a lot more sail area. We describe the different Genos essentially by their size and how much they go past the mast. So, for example, a jib would be just to fill this full total triangle area up. That would be a jib. 110% Geno goes just 10% past the mast, so it's 110% the size of a jib. We would then have a 130 Geno, which would be fill this whole area. It's 130% of the area, or 30% bigger than a standard jib. On my Capri, I have a 155 Geno, which goes from here all the way to the front, and it gives me lots of sail area. Each of these sails has an optimal wind range, and we're able to use the right sail depending upon the conditions of the day. There are a couple of abbreviations that we use when measuring boats, let's say. That the J dimension is the space from the tip of the forestay back to the mast. That's the J dimension. And the LP, luff perpendicular, is the distance from the perpendicular to the forestay back to the clew of the sail. And these are common marine design numbers that you will see used at different. An alternative to having many different sails of different sizes is something that we have on boats. It's called a roller furling system, or which enables us to make the sails shorter depending upon the conditions. So you would start out with a 155, and then if you needed to depower a little bit or reduce sail, you could then roll the sail around the forestay and make it smaller. So the way this works is the sail attaches to this mechanisms here. The halyard shackle pulls this piece of equipment up a foil. The sail is attached to the bottom of that deal, and then as you raise the halyard, the sail goes up the track. The track has grooves in it that holds the sail, like a bolt rope. Then what you can do then is the drum at the bottom has rope around it that then can coil or roll the jib extrusion and coil up the sail as it comes in. Here's an example of one for real life. So here's the drum, and you can see that there's an attachment, the rope that's coming back that you would roll up and down, roll the sail in and out. We're starting to see some instances where the masts also have a roller reefing system in them. A roller furling is probably the most correct term. And just like the extrusion that's on the jib, the sail is wrapped around it and then pulled inside the mast as we want to reduce the sail. It makes it a whole lot easier to hoist the sail because you just put it up once and then you roll the sail in and out, which is nice. But it does make the mast a little bit stiffer, and so it's a little less flexible, and we give up a little bit of the mast bend tuning that we might normally have. In addition to the main and the jib, some boats also have a spinnaker. And a spinnaker is used for going downwind or on reaches. And it's much more cloth available, which again gives us some more power. There are two types of spinnakers currently in use today. We've got the symmetrical, which is the sail is symmetrical on both sides of the sail, are the same size, same length, and things like that. And now in the more modern boats, they've come and started using asymmetrical. And what that is the front part of the sail is attached to the bow, and then the back part of the sail is much longer, and then it gives more cloth. And it's the advantage of the asymmetrical is it's a little easier to handle than a symmetrical one, and it has less gear attached to it too. And so that's why modern boats are some of the modern boats are going to the asymmetrical, because they can add a lot more sail area without adding extra crew to manage that stuff. If you were to go to a boat show in the wintertime or wherever you are where they're offering different types of sailboat parts, one of the things that you might run into is someone telling us about a Spinnakers sail sock. And what that does is it's a system that helps us get sails up and down. Those of you who have been out on a Thistler, Flying Scot, or any other boat with a spinnaker, one of the more traumatic things that goes on is the hoist and the douse of the spinnaker, because you've got a lot of cloth to manage. So if the wind is not in our favor, it can cause us to go swimming. And so the cruising people, who are often fewer crew, have developed this spinnaker sock. Gary has one on his boat, and we typically would show this, actually demonstrate how the sock works in a classroom. It fills up the entire classroom as we try to make this thing work. What happens is there's a bunch of material, this is a sock-like thing that you can pull up and down to take the wind out of the sail. So when you're hoisting it, you would hoist the sock up, and as that goes up, the sail fills. And then when you want to douse it, you pull the sock down, and then that takes the wind out of the sails, and then you can have it without any problem. The downside to the sock method is you've just got a lot of extra weight hanging up at the top of the mast when you're sailing around. If you're cruising, weight up doesn't matter. If you're trying to go fast, you want to reduce the amount of weight aloft because that just makes your boat a little quicker. If we were sailing in bigger waters, there's another sail that we might have on board just to give us more safety, and that's called a storm jib or a storm trysail. And so what we have here is it's a very small sail that fits, and it is reduced down. What it does is it enables us to keep the jib up and then reduces power dramatically. And we also have a trysail with the main, which is also much smaller. These sails are primarily used when you're caught out in open water, and can't get back to land. The storm jib, if you look at how that goes, the clew is very high up, so that when the bow dips down in the waves, the water can splash across the deck and not get caught in the sail, which then keeps the boat under control more. The storm trysail they're built out of heavy material, and you've got a rope sewn in all the edges so that it gets it extra strong. And instead of running, and then this doesn't even attach to the boom, it's just the back of the sail. The clew is actually attached to a cleat on the deck to give it more strength. There are a lot of different ways that sails are designed, and they have different characteristics. In modern days, the computers have helped us with this design work, as well as help us cut the cloth to optimize sail shape. Let's look at the panels to see how the various loads are spread on the sail. So let's take a look at this radial sail over here. If you can kind of see that we've got, that it lines up the fabrics with the load. And so on each fabric we have warp fibers that run the length of the fabric, and we've got fill fibers that run across the fabric. So in this radial case, we would have long warp fibers that run this way, and then we would have the fill fabrics to keep the stuff together going across it. And that the radial gives us a lot more strength. Now we've got these other sails. These are cross-cut sails, and what they do is the warp fibers run this way, and the fill fibers are just a little bit up and down. And what it does is it makes it really easy for the sailmakers to design the shape. We've got different characteristics that are also based upon the sail's design. A high aspect ratio says that the sail is very high compared to its foot. In this case here, the low aspect sail is not very tall, and the boom is much longer. So that kind of gives us an idea how the boat is going to perform. We've also, on the Spinnaker line, we've got many different sets here. We've got a radial head so that the sail area is rating, the strength is rating from the head, but then we've got cross-cut sails going across the foot. And here we've got a tri-radial, so that the radial head as well as the foot is spreading the loads across the corners. Here's an illustration of a fairly complex sail that's not uncommon in boats. In this case, it's called a full batten cross-cut mainsail. And in this, what we've got going on here is our battens, instead of just covering the narrow roach area, it actually goes from the front of the mast all the way back to the leech of the sail. And what this does is it enables us to control the sail shape a little bit just by using the battens, in addition to just stabilizing the roach area. We also can see in this sail here, this stuff here illustrates the tabling that is added to the sail to give it extra strength at these pressure points, load points for the sail. We also have, you can see these are the panels of the sail cloth, and what we would expect is that in these cross-cut panels, the cross-cut panels are actually laid on the sail perpendicular to the leech of the sail. So this area here is perpendicular to the cloth. We've also got a lot of different kind of sail materials that we've have come to use. Traditionally, the sails were made out of Dacron, which were fairly inexpensive. They're very strong. They resist stretch, and they cost a lot of money, but not as much as some of the other high-tech stuff. We've gone away from that to other type of sails where we actually have the fibers, rather than being built into the cloth, are actually laid on a mold and then formed between two slices of material like mylar, a piece of plastic, that they can lay these fibers out to match the loads of the sail, and then you don't have to, it holds its shape better. Let's go over the vocabulary for this chapter. The bolt rope, as you recall, is a rope sewn to the edge of the sail to reinforce the cloth as well as limit stretch. It goes into the cove that's in the boom or the mast to hold it in place. And we don't have to have a slide in order to use that, or a slug. The cove is that groove in the mast or boom where the bolt rope slides into. The roach is the part of the sail that extends past the straight line from the head to the clew. It's the part that, if we didn't have battens, would be fluttering without extra work. And some sails, self-tending, some sails you don't have to, are automatically retrim themselves when you tack. And so you don't have to readjust the sail points. This concludes section 5 on sails. Our next section will be on running rigging.